SwayamPrabha. Digital India. Educated India.
I am Dr. Rajiv Mishra, working as professor in Department of Computer Science at Indian Institute of Technology, Patna. The topic of today's lecture is Introduction to Cloud and its limitations to support low latency and RTT. RTT means round trip time. The content of this lecture is as follows. We will discuss the overview of cloud and edge computing. We will then discuss the functionalities of edge computing. We will explain you the current demand of cloud data center, and then we will show you how we are moving the services from cloud to the edge in the recent times. Then we are going to cover, since the edge computing is now complementing to the cloud computing. So, we have to understand the fundamentals of cloud computing. In that perspective, we will introduce you about the cloud computing concepts with the focus on what is new in today's cloud and how the cloud computing is different or distinguished from the previous generations of the distributed systems. Now, understanding the transition from cloud to the edge computing, or how the edge computing complements the cloud computing, we have to now understand this wave of innovation, that is the innovation happening in the cloud. So, for that we have to understand this cloud, which is the current state of the cloud. So, current state of the cloud says that it is nothing but a highly centralized set of resources. Once you say what do you mean by the resources we mean the compute, storage are the major resource. Third important resource is called the network. So, you can see that the cloud has highly centralized set of resources, and that means it has hundreds and thousands of computers with the storage and network connected together, called a cloud data center, and this is a highly centralized set of resources with the help of cloud data center. Now, cloud services, these resources required by different applications or applications which are running in the cloud, can access with the help of a client server computing. So, to get these resources accessed, so this particular cloud is giving a paradigm of the services in the form of a client server computing. So, therefore, the server means that the data center or the current or highly centralized set of resources, whereas the client depends, or the users of these services called resembles the client server mode of computing. So, this is the fundamental basics of the current state of the cloud. Third important thing is that the compute is going beyond the virtual machines. So, what do you mean by virtual machines? VMs means virtual machines. The cloud resources are provided in the form of virtual machines, that is compute, storage and the network is called a virtual machines. So, the cloud often gives the virtual machines, that is a de facto standard, but now the compute is going beyond the virtual machines in the current state of the cloud, as the containers, virtual machines are being replaced with the containers in the mainstream of a cloud. Second important thing is that storage, which is a resource provided by the cloud. Now, this storage is complemented with the content delivery network, and content delivery network depends upon or is based on the replication of that particular storage at different places where this particular storage objects are cached at different edge locations and they are replicated. So, by replicated and caching, this concept of a content delivery network will give the storage at a very high speed or quickly to access those objects, stored objects, with the help of edge locations. This edge locations is quite different than the edge computing, which we are now discussing. Now, another important thing about the current state of the cloud is the network stack, which is programmable. Software defined network principles are applied to make this network stack programmable, and this provides to enable having the hybrid scenario. So, this all covers the current state of the cloud. So, this is current state of the cloud is going into the transformation or is moving through the waves of innovation. It started at the cloud, but initially the cloud is globally available, having unlimited compute resource. That is why cloud is very powerful. Now, this cloud, why this cloud is moving in this way? What are the uses? What are the use case of that particular cloud? The most important use case is Internet of Things. So, Internet of Things often uses cloud as a service platform, that is IoT as a service, software as a service platform is the key driver of the public cloud. Meaning to say that this Internet of Things are the devices which are equipped with the sensors and the actuators, they are often called things. So, when we say things, means it has the capability of sending the data or the signals of the sensors to the cloud, and this particular data which is sent by the IoT will be managed centrally by the cloud. Now, the question is that why at all this is not one IoT device, but billions of devices requires the cloud to manage the IoT devices. Not only the manage the devices, but also the cloud is used to store the data which is sent by billions of IoT devices. Now, the question comes that why this particular data requires the cloud. So, the only purpose or the basic purpose of using the cloud by the IoT application is to perform the machine learning or the artificial intelligence which is there at the cloud. So, the data which is sent by the IoT devices are often sent to the cloud. Why? To do the machine learning which is happening inside cloud. Now, the question is, if machine learning can happen close to the IoT device, then no need of sending all the IoT data to the cloud and thereby giving the birth to the edge computing. So, this wave of innovation into the cloud due to the enormous requirement by the industries in the form of IoT applications are giving rise that why not everything to be done in the cloud, why not it is to be done outside of the cloud, very close to the IoT devices. And therefore, not only that, billions and more than that devices can be supported in this particular manner. So, therefore, this particular machine learning, that is the rise of AI and ML models which are often trained in the cloud, and for that the cloud has become a de facto standard, but it is being shown that this particular training can be done at the cloud, but these trained model can be deployed at the edge to make this inferencing usable for various predictive analytics of industrial use cases. So, therefore, this particular wave of innovation, that is to do the machine learning very close to the devices, thereby the need of the cloud not to send all the data to the cloud can be met, and therefore, this particular breakthrough in the intelligence capabilities in the cloud and on the edge is being evolved. Now, let us see the typical application, or that is called industrial IoT application. So, industrial IoT, you know that this particular oil and gas industries now are deploying these platforms in the sea shore or inside the sea platform for oil exploration, drilling and supplying the oils. Now, it requires automatic monitoring with the help of sensors. So, they are called industrial IoT sensors, and these sensors are deployed in a large number, and these sensors often sends the data regularly to the cloud. Now, here you can see that the huge amounts of data are being produced in oil and gas industry by the sensors like temperature, pressure, velocity, and the size of such data is ranges from terabyte to the petabyte per second. You see that this amount of data, this is being sent per second. Therefore, it is highly impractical to send all the data to the cloud environment for processing due to the number of factors such as high cost of connectivity needed into the cloud and the high cost of bandwidth needed to transport, ship all the data per second generated by such IoT devices. And foremost important thing is that sending all the data for doing intelligence computation requires a lot of time, that is called latency. So, that means important latency sensitive applications will not take the use of sending the data to the cloud for intelligence computation. And also sending all the data to the cloud poses the risk, security risks such as cyber security attacks. So, industries are also not very good or not very comfortable in sending all the data to the cloud. So, therefore, alternative is to have this intelligence performed at the edge, and this will avoid sending the data to the cloud. In this case, you can have the less than 1% of the data being generated to be sent to the cloud. So, this becomes a very important application, that is called edge computing in that particular way of supporting. So, let us see the edge computing. What is the edge computing? So, edge computing, we have understood through the wave of innovation that edge computing is going to make this cloud truly distributed. From earlier the cloud was highly centralized, global centralized. Now, with the help of edge computing, it will make the cloud truly distributed. Once you say distributed, that means scalability will be there. It is going to support large number of IoT deployment. Now, the next part of the edge computing is that it will move the core cloud services close to the origin of the data, and thereby avoiding the data to be sent to the cloud for doing the computation if those kind of capabilities are brought closer to the source of data. Third important thing is that this edge mimics the public cloud platform capabilities. So, that means whatever you can perform at the public cloud, those kind of capabilities are also being created at the edge. So, edge mimics the public cloud capabilities. Fourth important thing is that delivers the storage, compute and the network services which earlier used to do by the cloud is also being done locally with the help of edge computing. The edge computing reduces the latency by avoiding the round trip time to the cloud. What do you mean by this round trip time is shown by this particular example. So, RTT, round trip time. So, round trip says that the data which is being generated by an IoT device here, let us say that in the oil exploration platform, need to be sent to the cloud through the network. It requires a lot of high costs and latency of sending the data, that is called round trip, and round trip means sending the data, doing the computation intelligence at the cloud and then getting the results back, called round trip time. Sending the data, that is latency, let us say a delta 1 time is required, and then returning the results back, this is called round trip, and doing the computation, let us say that computation time is that. So, total time is called round trip delay. So, round trip time is sending the data to the cloud for doing the computation, getting back, incurs a lot of a substantial amount of round trip time, So, this you can avoid by the way of edge computing. So, edge computing will save by not sending the data to the cloud, yet it can perform the intelligence computation there itself. Important thing is that related to this particular concept is that it will bring into the data sovereignty by keeping the data where it is actually belongs and saving on the cloud and the bandwidth usages. Now, with this, when we say that the edge computing mimics the cloud like capabilities locally, that is where very close to the source. So, what do you mean by that? What are the capabilities cloud is having which is needed by the edge? So, let us see some of the functionalities. It is not all listed, but it give you a fair idea about what should be there into the edge and what is the edge computing supposed to be understanding here in these as the concepts are concerned. Now, when you say that IoT is sending the data directly to the cloud, this particular procedure or the functionality of the cloud is called data ingestion. So, cloud has a lot of data ingestion capabilities, and also it is being enabled with the help of machine to machine brokers, and the important protocol in this is called MQTT. Now, this kind of capabilities are also to be provided at the edge, then only the edge computing will grow at the pace which is being needed by the application. So, data ingestion and machine to machine brokers are also needed for the edge. Now, next important thing is the object storage. So, object storage is often the storage services which the cloud is providing to store the large data sets, maybe if it is the video feed of the camera or maybe IoT sensor data, that is called time series databases are required. In that case, objects are stored over there. These object storage in some form or a small form has to be also enabled at the edge. You with the help of a small data center, they are called edge data centers. Function as a service, that means you know that the functions which are being provided there in the cloud is being accessible as a service, REST API or some of the examples. Now, another important thing is that most of the applications are designed using Docker and container. So, containers are also to be enabled in edge. So, other than virtual machines or virtualization of an edge should also be the functionality to support the containers in the edge computing. Edge computing also has to enable the distributed computing principles like cloud computing, and you know that NoSQL database, that is used for time series database which is implemented in the cloud, that capabilities also has to be there with the edge computing. Similarly, stream processing and machine learning models, some of them. So, these are some of the functionalities which the edge computing should have. So, let us understand this edge computing underlying principles should have the Docker container principles enabled, Kubernetes, MQTT, Kafka, time and clock synchronization principles of a distributed system, and key value stores store at the edge. Recent advantage of the machine learning inferences at the edge for the use case such as predictive maintenance, image classifier, self-driving car for different IoT application also requires that implementations at the edge. So, these are all functionalities which are summarized here through the icons. So, this is the icon for the edge computing, and it is quite different than you can see that the cloud computing. Cloud is thick, the edge is thin, and similarly the Amazon Web Service. So, this edge computing will enable the concepts, let us say that Kubernetes, which is the container orchestrator, and then this particular edge will provide the low latency applications such as self-driving car. So, let us see the cloud data center, what is the current demand for that. So, in the next decade we will continue to see sky rocketing growth in the number of IoT connected mobile and machine to machine learning device which will handle the amounts of IP traffic. Meaning to say that, so these particular devices are going to increase, but for that it requires the support of M2M devices. Now, these consumers will demand faster Wi-Fi services and application delivery from the online providers, such as autonomous vehicles will require the real time communication with the local processing resources to guarantee safety. Now, these IP networks cannot handle this high speed data transmission that tomorrow's connected devices will require. So, instead another model we have to now realize that instead of depending upon the cloud data center and that to depend upon the today's IP network. So, traditional IP architecture, the data must often travel hundreds of miles over the network between the end users or the devices and the cloud resources. So, the current state of the cloud results in the latency or the slow delivery of the time sensitive data. So, they are not supported. So, take this particular example in the current. So, demand is that in the current 4G services are often being served by the cloud data center. So, this cloud data center you know that incurs more than around 100 milliseconds of latency. So, the latency sensitive applications such as self driving car, which requires only less than 1 millisecond latency, cannot be supported with the technologies such as self driving car, such as 4G. Now, in the upcoming 5G technologies requires not the centralized cloud data center, but every base station will have its own data center called micro data center or edge data centers they are called. So, thousands of micro data centers under the cell towers are going to be deployed, and this way the compute is to be done locally and less than 5 miles away all the computation is to be carried out instead of sending a long haul to the cloud data center. Therefore, this edge computing is also enabling 5G to support the latency sensitive application. By this way, you can see this latency which is being guaranteed by 5G is even less than 1 millisecond. So, latency sensitive applications are requiring this kind of technology. So, this particular technology, that is edge computing, is enabling 5G, and this enables the way for the new kind of applications. So, let us see the solution for that. What is then edge data center? So, solution to reducing the latency lies in the edge computing by establishing IT deployment for the cloud based services in the edge data center in the localized area. We effectively bring IT resources close to the end users and the devices. Now, this helps us achieve efficient high speed delivery of the applications and the data. So, edge data centers are typically located on the edge of the network with the connections back to the centralized cloud core. Now, instead of bringing the users and the devices to the data center like cloud, we are bringing the power of data center to the users or the devices with the help of edge computing. So, edge computing relies on a distributed data center architecture in which IT cloud servers housed in the edge data centers are deployed on outer edge of the network. So, by bringing the IT resources close to the end users or the devices they serve, we can achieve high speed and low latency. So, this is the principle behind the edge data center. The example you can see over here, the cloud is quite far from the connected devices, whereas the edge, which is very close to the IoT or connected devices, these edge data centers are forming and making this compute available close to the devices, not away from the devices, and thereby paving a way to the new set of applications which are called latency sensitive applications and also does not depend upon the network bandwidth. So, edge data center is the solution, and here we can see that when we say that edge data center, what are the components, how the things are going to be benefited out of that edge data center. So, different type of paradigms are there for realizing that. Another question is why moving the cloud services to the edge. So, there are 4 main benefits of moving the data center, that is the cloud data center, to the edge, which involves the improvement to the 4 factors called latency, bandwidth, operating cost and security. So, the latency says that the edge data center facilitates the lower latency, meaning that much faster response time will be achieved. So, locating the compute and storage closer to the end users reduces the physical distance that the data packet needs to traverse, as well as the number of hops involved, which lowers the probability of hitting the transmission path where the data flow is impaired. So, therefore, latency is one of the most important criteria here for moving the cloud services to the edge. Second important thing is that this bandwidth. So, edge data centers process the data locally, that is reducing the volume of data traffic flowing from the central servers. So, that is being avoided. In turn, the greater bandwidth across the users broader network becomes available. So, which improves the overall network performance. Third important thing is the operating cost. So, because edge data center reduce the volume of traffic flowing to and from the central servers, they inherently reduce the cost of data transmission and routing, which is important for high bandwidth applications. More specifically, the edge data centers lessen the number of necessary high cost circuits and interconnection hubs, leading back to the regional or the cloud data centers by moving the compute and storage closer to the end users. Fourth important thing is about the security, that is the edge data centers enhance the security by reducing the amount of sensitive data to be transmitted, then limiting the amount of data stored in the individual location given their decentralized architecture, decreasing the broader network vulnerabilities because it breaches can be the ring fenced for the portion of the network that they compromise. So, all 4 are factors: latency, bandwidth, operating cost and security, which now are giving the rise of moving the cloud services to the edge. So, let us see that how that is being brought. This is being brought with the concept of a edge data center. So, let us see what do you mean by the edge data center. So, the major benefit of edge data center is the quick delivery of the service with minimal delay, thanks to the use of edge caching. Now, latency may be a big issue for the organization that have to work with Internet of Things, big data, cloud and streaming services. So, the edge devices, so the edge data center can be used to provide high performance with a low level of latency to the users, making for a better user experience. Typically, the edge data center will connect to a larger and central data center or a multiple other edge data center, and such examples are shown over here. So, this is the edge data centers which are now connected to the regional data centers and quite far away, which is the cloud data center. So, data is processed as close as to the end use is possible, while less integral or the time centric data can be sent to the central data center for processing. So, this allows the organization to reduce the latency. Now, let us understand the concepts of cloud computing, which is very much needed in the development of edge computing. So, the cloud, you know, that was created out of the hype long back, that is in 2009 forecasting agencies Gartner in 2009 expected or forecasted that the revenue will be soar by, let us say that 4 years in so much of billion, and it represents the 19% of IT spending will be generating into the cloud. IDC is another forecasting agency. It also forecasted the same, and for Forrester also forecasted the same. And it was also envisaged that the companies and even the government will be using the cloud. So, therefore, the entire hype has oriented the development of the cloud, and various vendors are now aligned to that. Now, there are various cloud providers was giving out this particular service because of the good amount of revenue or the IT spending can be there with the cloud providers. So, important cloud providers are prominent cloud providers are Amazon, Microsoft, Google, Rackspace, Salesforce, Tengen, Oracle, VMware, and so on. Out of them, the most popular cloud provider which is providing these cloud services are Amazon Web Service, AWS. Now, Amazon Web Service provides its cloud facility or cloud services in 3 different types of flavors. The first one is called Elastic Compute Cloud, EC2, which is nothing but a compute resource service where VMs are being given to the users. Second important service which AWS provides is called Simple Storage Service, S3, that is for the storage, to store the object storage service. Third important thing is EBS, that is Elastic Block Storage, that is with the virtual machine or VM, that is EC2 instances, it requires Elastic Block Storage. So, there are 3 different type of service. So, the name of the cloud which Microsoft provides called Azure, name of the cloud which Google provides called Google Compute Engine. Similarly, for different other type of cloud providers which are being provided, which are being available. Why this cloud? Why the customer? If the customer wants to save time and money, for that this cloud is being created and developed. So, let us understand what is the cloud. So, the advantages, so advances in the virtualization makes it possible to see the growth of internet cloud as the new computing paradigm. So, dramatic difference between the developing software for millions to use as a service versus distributing the software to run on their PCs has created the development of the cloud, and this is what is the cloud. Various people are seeing the different definitions long back, but now everything is stabilized. Some people view the cloud still as the grid cluster, which changes through the virtualization technique. So, the virtualization is the key technology which has given the rise to the cloud computing. So, let us see what is there inside cloud. What is cloud? So, inside cloud, if you see, let us say that a single site cloud, also known as the data center, which has the compute nodes. So, hundreds and thousands of compute nodes are there, and which are grouped into the racks, and these racks and these nodes called compute nodes inside racks are often connected with the switches, and these racks are connected with the help of a tree like topology called 3-tier architecture in this network topology. Now, you know that the front end for submitting the jobs and receiving the client requests is enabled here in 3-tier architecture, and different software services are being supported here to access this data center in a client server architecture. Second important aspect about the cloud is that it is a geographically distributed cloud, because it is not only one data center, but it is multiple data center at multiple sites cloud. Then it is called geographically distributed cloud. So, it consists of multiple such site. One such site we have told you, it is called data center. where each site perhaps with a different structure and services is being providing. Cloud computing paradigm distinguishes from the distributed computing in the following manner, that the cloud computing can be built with physical or the virtualized resources over the large data center that are nothing but the distributed computing principles. So, if you trace back the history, what you will find is that the 1940s the data center were still now that concept is moved in the form of cloud. So, cloud is also forming in the form of a data center, but the data center of 1940s are quite different than today's data center, which is supported by virtualization. Now, these are some of the technologies which are driving the cloud, and so let us see the features of today's cloud. So, what are the important features which distinguishes today's cloud than traditional mode of computation? So, there are 4 features. If the 4 features are as follows, the first one is called the massive scale. So, massive scale means that very large data centers are required here in today's cloud, and each data center will contain hundreds and thousands of node, that is called servers, and your application should be such that it requires so many number of servers to run across, and your your application will scale with as many servers as is being added, and this is called the massive scale. So, massive scale is one of the important features of today's cloud. You can see that the cloud data center has the centralized, highly centralized resources, set of resources globally available. So, to access it you require the client server paradigm, and this is one of the important features that it has developed in this massive scale, that is in today's features of the cloud. Second important thing is that how do you access the centralized or a massive scale, that is the resources which are available by these cloud providers. So, that particular concept is called on demand access. So, on demand access, that means that these resources are available and with a model which is called pay as you go. You do not have to pay any upfront commitment, whatever you want to use you have to pay and use it. This particular type of service called on demand access to the cloud service, and it can be made available to anyone and everyone. Third important feature of today's cloud is called data intensive nature of computation. What do you mean by data intensive nature of computation? Data intensive nature says that the size of the data set is too huge, and which was earlier megabyte has now become terabyte and petabyte in today's workloads. So, today's workloads are daily logs, forensics, web data. This becomes a huge data set which requires the computation to be done and storage of it. So, therefore, this particular massive scale kind of facility which is created by today's cloud supports data intensive nature of computation. So, if it is a data intensive nature of computation, means data is so big, that so huge, that is in the petabyte and zettabyte, then in that case you cannot move the data for the computation. So, computation has to be near wherever the data is stored, called data intensive nature of computation. Now, for this kind of model, that is data intensive nature of computation, how do you support new programming paradigms are being created, and that is another feature of today's cloud. So, what are the new cloud computing paradigm which is meant for this data intensive nature of computation? So, these new cloud computing paradigms are the MapReduce, Hadoop, NoSQL, Cassandra, MongoDB and many others. Now, having understood these 4 different features which classifies today's cloud, the combination of one or more of these give rise to a novel and unsolved distributed computing problems in the cloud computing. So, we will say that if one or more of these are present, then you say that it is a cloud scale or a cloud computing problem. whereas, if it is not present, all these 4 features are not present, then it is simply a distributed computing problem, not a cloud computing problem. Now, we have to now look into what do you mean by the massive scale. Massive scale means that the size of the node, computing node is required to run those applications. For example, Facebook is an application. In 2009, it requires 30,000 nodes or the servers to run that particular application. 180,000 servers were required in 2012, and now it is much more. You know that Facebook is still running, but now the scale is more. So, the next massive scale example is about the Microsoft. Microsoft runs a application which is called a Bing search engine. For that, it requires 80,000 servers long back, and in 2013 it requires 110K different servers in 4 different sites for other applications. Now, coming to AWS EC2, it requires 40,000 machines in 2009, and each machine was of 8 cores, and you can see that now this particular Amazon EC2 for that it requires even much more than what was in 2009. As far as the Google is concerned, how many number of servers they are using, they have not yet disclosed. It is much more. So, that is called the massive scale. These applications which are running on the internet often are cloud scale applications, and it is categorized as the massive scale. So, what do you mean by that massive scale? That means, these are all so many hundreds and thousands of servers are stored in a place which is called data center, and from inside view of a data center is shown here. And you know that these are called racks, which now stores or which look where the servers are located. And lot of servers are there inside. One view of a rack is shown that so many servers are now can see so many servers are there here. You can see that here so many servers are there in data center in the racks, and so many racks are here. So, overall you can see that this particular facility, which is called a data center, will be there to manage the massive scale and to support the cloud computing. That is 10,000 to tens and hundreds and thousands of the machines are stored here in this form, in the form of the rack, and then you see lot of networking will be there. So, 3 tier hierarchical networks will connect all of these hundreds and thousands of servers, and therefore, to access through the application client server. So, this is the example of a massive scales. Now, this particular massive scale requires huge power and therefore, energy, and also often when so much of power is required, so lot of heat will be generated, and that heat is to be, and then lot of cooling technologies will be in place to support the cloud. So, as far as that is power or carbon footprint, if you can see these cloud data center is a huge, that is equal to the aviation industries if you make a comparison. So, aviation industries carbon footprint is equivalent to the cloud data center or the cloud computing carbon footprint. So, obviously, the huge way it has to be now replaced. So, the power and energy and water is there for cooling the facility, and the matrix which is used is called water usage efficiency. So, water usage efficiency means that annual water usage divided by IT equipment energy if it is low, then it is good. Similarly, the PUE called power usage efficiency, that is the total facility power divided by IT equipment, low is good. So, Google claims that it is achieving close to 1 and that is good. So, a lot of cooling technologies are also in place in the data center. Now, second important feature of a cloud computing is on demand access, is also called as a service classification. So, the most important as a service classification which the cloud provider often gives in the form of virtual machine is called infrastructure as a service. So, it gets access to the flexible computing and the storage infrastructure, and the virtualization is the key factor, is the key technology which brings this infrastructure as a service. That is, the entire cloud infrastructure is now, or the data center is now virtualized, that is made enable for sharing across multiple users on who can pay on demand for its usage. Examples are the Amazon Web Service provides the infrastructure service in the form of EC2 and S3. EC2 is the compute and S3 is the storage. OpenStack, Eclipse, Redis, Microsoft Azure, Google Cloud also provides this infrastructure as a service. Second important type of on demand service called platform as a service. So, platform as a service also called a PaaS. So, platform means that it gets access to the flexible computing and storage infrastructure coupled with the software platform, often tightly coupled. So, Google's app engine provides the platforms such as Python, Java, Go. It is the platform is being provided, programmer need not have to worry about underlying system or the infrastructure. Directly Python programs, Python environment is provided, it can write a Python program or a Java program and it can run its job. Next important on demand access is called software as a service, SaaS model, and it get access to the software services when you need them. And examples are, for example, Google Doc, Microsoft Office, which comes on demand, is an example of a software as a service. So, even you do not have to worry about programming, you can directly access, for example, whenever you want to access the Google Docs or a Microsoft Office on demand. Third important feature of a cloud is called data intensive nature of computing. So, data intensive nature of a computing says that typically store the data at the data centers. Now, if the data is so huge, it cannot move out for cannot move to other location for doing the computations. So, therefore, the compute nodes are to be placed nearby, and that type of concept is called data intensive nature of computation. So, compute node runs the computation services, and this architecture, this kind of paradigm called data intensive nature of computation is quite different than computation intensive nature of computation, where you can see that the data has to move where the CPU or the processors are there, and the processor required to be very powerful. So, this is a paradigm shift. Now, we are now the technology which says that data intensive nature data is so huge, it cannot there in compute intensive data is not that big, where the CPU or the computers were very powerful. Here the computers are ordinary commodity machines, but in a large numbers, and the data intensive nature of computation is being supported. So, in a data intensive nature of computation, the focus shift from computation to the data, and where the CPU utilization is no longer more important like in computation intensive computing, instead of IO and disk and network, all things are there. Now, fourth important paradigm is called cloud computing paradigms. Four important features. So, this particular cloud computing paradigm, so we have to understand about that. So, Google has given the MapReduce is a cloud computing programming paradigm, and using MapReduce you can write a cloud scale applications which can run. and a similar kind of cloud programming paradigm is provided by even Amazon. Google has already given this, then Yahoo has given this Hadoop, Facebook is also Hadoop, and MySQL, NoSQL is the industry standard for this new cloud computing paradigm. Now, coming to the categories of the cloud, there are two types of cloud. One is called public cloud, the other is called the private cloud. Public cloud are accessible only to the company employees, and such popular vendors which create the private cloud are called VMware, Microsoft Azure, and so on. Public cloud are provide the services on any paying customer. Examples of a large scale public cloud services include Amazon EC2, Google App Engine, and so on. Now, the question is, when you are starting a new company, should you use a public cloud or purchase your own cloud? So, this particular question can be answered by way of simple calculation, that is called economics model for choosing the cloud or buying upfront the IT spending. So, let us say that a medium sized organization wishes to run the service for, let us say, m months, and this service requires 128 servers, and each server is, let us say, that total there is 1024 cores, and it requires the storage for 524 terabytes. Now, if you let us say that you lease through the public cloud services via AWS with the monthly billing. So, you can see that S3 costs is, let us say, $0.12 per GB month, and EC2 cost is, let us 0.10 per CPU hour. So, therefore, the storage cost for 524 terabyte will become 0.12 multiplied by 524 multiplied by 1000 terabyte conversion, that comes out to be $62,000 total cost. If you calculate storage per CPU will become 62,000 for storage, and CPU will be 0.10 multiplied by 1024, then multiplied by, that is core, that is multiplied by 24 multiplied by 30, that comes out to be $136K. So, if you own this, own means if you purchase this IT infrastructure, what will be that monthly cost for that storage? Let us say that you buy upfront $349K $1,000 divided by total months, how many months will you are going to use your own IT spending. So, if you split, so if you calculate the break even analysis, more preferably to own, if let us say that $349K divided by M is less than 62K for storage, and if it is $155K divided by M plus 7.5K is less than 136K. If you calculate this two simple equation break even points, you will get that if M is greater than 5.55 months, that is more than 6 months, if you require to use this storage of 524 terabyte. So, instead of going for the cloud, you can own that. Break even for compute is that if let us say that you require the compute infrastructure for more than 12 months, then you should own that. So, the startups therefore often use clouds a lot. Why? Because their break even point even is less than that particular calculation what we have seen. So, cloud provides benefit monetarily most from the storage. So, therefore, what we have so far seen is the 4 features and then we have also seen 2 different type of clouds, and let us summarize this conclusion. So, conclusion of this lecture, what we have shown you that we are moving from cloud services to the edge due to the several reasons which we have now stated. The most important reason is that using the cloud services in most of the application needs to access the cloud directly, and that requires a lot of round trip time, and therefore, a lot of latencies are being added. Not only latencies, but a lot of cost is also incurring, that you are using bandwidth for sending the data of a huge volume to the cloud. There the computation is carried out and then comes back. So, this particular model, which is highly centralized model called cloud computing, is not good for latency sensitive applications such as self driving car and so on. Whereas, the new kind of concept that instead of sending the entire data to the cloud for doing the computation, rather that particular cloud like services can be brought very close to IoT devices. So, that is called the edge computing. So, edge computing complements the cloud computing, and this complements this enables the use of the new kind of latency sensitive application. So, understanding that edge computing has to mimic the cloud like services. So, we have to now understand what is a cloud. So, in this lecture we have also discussed the cloud computing, and we have traced back some of the important concepts of a cloud data center, that is massive scale and 4 different important features, on demand access. So, all these things if we consider as the characteristics of a cloud computing problem, we have also understood the concepts of edge and its functionality. So, with this let us conclude this particular lecture. Thank you.